Homework 12, Polynomial Division, Factor Theorem, and Rational Zero Theorem, Video 2. Let's take a look at another long division problem, and this one actually has 2 points that I want to make. One of them is a little obvious, one of them a little more subtle. Number 1, our divisor has a higher degree, so instead of dividing by something of degree 1, we're dividing by something of degree 2. That really doesn't change anything, it just makes for what seems like a longer problem. But the other one's a little more stealthy. If you'll notice in the dividend, there's a missing power. By missing power, I mean from the highest power, every power below that should be represented. Here's x to the third power. Here's x to the second power. Here's x to the... There is no x to the first power. This polynomial is missing the x term, the x to the first power term. And why is it important to make that observation? Because when you're doing long division, you take for granted that all your like terms will line up. That's assuming that all powers are represented. If there's one power missing, then at some point your like terms are not going to line up. So what do you do when you set up a long division problem and there's a missing term? Well, you represent it. How do you represent it? Well, by writing how many x terms are there. How many x terms are in there? None. There's an x cubed term and an x squared term, but there's no x term. Literally, no x's. So any term that's missing, you represent with a coefficient of +0. It doesn't matter if it's plus or minus, I just always use plus. So let's set this one up. Our dividend is, our divisor is 2x squared plus 7x minus 3. And our dividend is 6x to the third plus 13x to the second. And normally I would be expecting my x term. There are none, so I'm going to represent it with +0x. And then the constant plus 15. You'll see in a moment why that x term is necessary, or you can get away with it, but it sure is convenient. All right, let's go through the motions. I'm going to go through them a little bit more succinctly in this example. To start, we divide the leading terms of the dividend and the divisor and the dividend. So we need to figure out what 6x to the third power divided by 2x to the second power is. Well, 6 divided by 2 is just 3, and when you have one power divided by another, you just subtract the exponents. So 3 minus 2 is 1. 6x to the third divided by 2x squared is 3x. Let's put that over the x term that we wrote in. That's not why I needed it there, but that's where I'm going to put it. Remember what happens next. Once you figure out the first term in the quotient on the top, and I don't think I ever wrote the word quotient, Q-U-O-T-I-E-N-T, is the correct word for the answer to a division problem. Once you figure out the first term in the quotient, it gets multiplied by the entire dividend. Divisor, don't usually get those words mixed up. So if I multiply 3x times all of this by distributing and line up like terms, 3x times 2x squared, 3 times 2 is 6, x times x squared, add the exponents, x to the third, those match what I was expecting that. 3x times positive 7x, positive times positive is positive, 3 times 7 is 21, x times x is x squared. And then lastly, 3x times negative 3. Positive times negative is negative. 3 times 3 is 9. And there's just the one x. And then subtract by changing all the signs and combining like terms. So this 6x cubed becomes negative. The positive 21x squared becomes negative. And the negative 9x becomes positive. Here's where having the missing term represented is convenient. I'm about to combine like terms. If this plus 0x were not there, then the plus 15 would be, and these wouldn't combine. You might try to combine them incorrectly, but they should never be combined. Problem avoided since I represented the missing term. Now let's combine. The x cubes cancel. Here we have 13x squared and negative 21x squared. I'm still going to get an x squared term, I just have to combine the coefficients. 13 and negative 21, I believe, is negative 8. Positive 0x and positive 9x is positive 9x. And now bring down the next term. Once you've brought down the last term, you only have to go through one more time. So let's do it again. And remember, you set it off by dividing the leading coefficient of the dividend by the leading coefficient of the divisor. So negative 8x squared divided by 2x squared. Negative divided by positive is negative. 8 divided by 2 is 4. The x squareds cancel. The next and final term in the quotient is going to be negative 4. But that negative 4 gets distributed all over here. So let's take it term by term. Negative 4 times 2x squared is negative 8x squared. Good, those were supposed to match. Negative 4 times positive 7x is negative 28x. And negative 4 times negative 3 is positive 12. If you ever forget what to do, ask yourself, what would I do if these were just numbers? The next move would be to subtract, but in this context, it's easier to change signs and combine. This negative 8x squared becomes positive, the negative 28x becomes positive, and the positive 12 becomes negative. Combine like terms, the x squareds cancel, that was expected. Positive 9x and positive 8x is positive 37x. Positive 15 and negative 12 is positive 3. And the division problem is over. Why? There are no more terms to bring down. You might be taken aback by the fact that we still have an x, but there's a little rule of thumb about polynomial long division. You keep going until this power is less than that one. Because if it's not, then when you put them on top of each other, at the very worst, you'll cancel your x's or you'll have some left over. So that's really the rule of thumb for when it stops. And if you want to be more specific, more technically correct, you stop when the degree of the remainder, the highest power in the remainder, is less than the degree of the divisor. In this case, the degree is 1 over there, the degree is 2 here, the division problem is over. Plus the fact that there's nothing else to bring down. All right, so we have a pretty chunky remainder, but we do the same thing with it that we did before. The remainder, 37x plus 3, gets written on top of the divisor, 2x squared plus 7x minus 3. And that whole fraction gets added onto the quotient to make your final answer. So long division is called long for a reason. It's my list of things to do over here. But it's just like number long division. You just have to watch out for missing terms. You have to be very careful when you're doing the leading coefficient, leading term divided by the leading term. And be very careful when it comes to subtracting because you're subtracting multiple terms simultaneously.